Okay, so let's talk about radian measure, which is always another point of confusion or contention when we start doing trigonometry, because nobody understands it really. What? I don't get it. But I like to look at things. Probably start realizing look at things very simply, looking at the I call it the easy way. And as you can see right here, we have the same unit circle we had in the last video. 30-degree angle is still there. We have the protractor there. What I'm going to do now, I'm going to just take this protractor and turn it into a bigger one, 360-degree one. And now let's talk about how the radian measure sets up. So basically what I do, I just take this thing right here and I just swing it, oops, not that, swing it over there. This right here, I want this to be there. Take this and bring it right around here. When I bring this right over here like this, stop right here, we call that pi. I don't want to call it pi, but that's what we call it. And it looks like this, pi. So if this part from here to here is pi, if I were to go the same distance from here back around to here again, I've gone the same distance I had before, so we're twice as far. So this should be, you guessed it, 2 pi. Who knew? Now, let's take the top part here and let's divide it in half. And then we can take the bottom and divide it in half as well. So I divided the top part in half. Well, I can divide anything in half by dividing it by 2. So 90 degrees. So come up here. Oops. Here we go. I'm doing it right. I'm using the arrow. I go up here and you see it hit 90 degrees. That's halfway to pi. So my 90 degrees is pi over 2. So I'm just going to take that and move it over here. Move it there. It's pi over 2. So what I'm going to do now is going to be pretty interesting. You're going to see what happens. Which I really like this part because no one ever shows you this thing ever. I don't know why you don't do it this way, but I like it this way. So what I'm going to do is just take this little thing here. So I'm going to come around here. So this is, okay, pi over 2. Keep coming down here. But this, from here to here is pi over 2. Then from here to here is pi over 2 as well. So right here, what this really means, it's actually 2 pi. This is pretty neat. Watch what happens. 2 pi over 2. And guess what? The 2's cancel. And you have that. What? It's amazing. And if I were to keep that going, down here, so, oops, be careful, down here, so remember this was pi over 2, 2 pi over 2, and, oh well, it's easier, and it becomes 3 pi over 2, and as I keep going around, you got it, who knew, 4 pi over 2. 4 pi over 2. And guess what? This reduces, you got it, to 2 pi. Wow. This is crazy. Can't be that easy. This must be some trick to this stuff. Well, let's break it down again. Alright, so let's just say here, top part was broken in 2 pieces before. Let's break it into 4 pieces. So now it's going to look like this. If I want 4 pieces, it'll be, I'll have a line right here. Oops. So I'll have a line right there. Now that's 45 degrees on the left hand. 45 is in there. That's that. Here. 45 is in there. So if that's this 45, it's the pi over 2 is 90, and it's this is halfway to pi over 2. Well, halfway pi over 2. Halfway to pi over 2. Oh, no. Let's say here. Pi over 2. Halfway to there. You guessed it. It's going to be pi pi over 4. And we want to double check that. Pi is 180 degrees. 180 divided by 4 is 45 degrees. What? It's that easy. No one ever showed me that. Well, this gets even crazier because now this is actually, you see how I'm putting in the numbers for my radians now? This is actually pi over 4. But as I keep going, it just comes up here. And now that I'm in pi over 4s, this is going to be, let's put this, I love it. This is going to be, of course, 2 pi over 4, 2 pi over 4, which reduces to pi over 2. Wow. Isn't that wicked? Who knew that? Alright, so let's keep going. You can do this as many times as you want, and you can fill in all the main angles for unit circle. And down here, here. Oh, sorry. 10, 20, 30, 40, 135. Right the first time. So I took that angle. Now put that over here. See if that's going to be 35. Over here. 35. Keep overshooting. Here. 35. You see, you get my point. So this is going to be pi over 4, 2 pi over 4, and of course now it's going to be 3 pi over 4. And down here, with the next section, this is going to be cool. But wait for it. Watch what happens. Moving it down here. You got it. 4 pi over 4. 4 pi over 4, and guess what? These cancel, and we're back to here again. That's just crazy, eh? So then we can do this all day. So down here, 255. 45 degrees more, and it's going to be 5 pi over 4, because this was 4 pi over 4, and then it's going to be 5 pi over 4. This is ridiculous. This is this easy, sure is. Come down here, and guess what? This is going to be 6 pi over 4. Which reduces to 3 pi over 2. It's amazing, eh? And by the time I get around here, this is going to be 6 pi over 2. I'm sorry, 6 pi over 4. Oops, I'm back here. Then I get over this way, it's going to be the other way. 7 pi over 4. And then up here, 8 pi over 4. Moves over a bit. And 8 pi over 4. 8 pi over 4, you guessed it, is 2 pi. There you go. That's radian measure. You can go all around there, 5 pi over 4, 6 pi over 4, and basically any angle you want, you can break it down like that, and that's as easy as it gets. It's pretty basic when you think about it. And that's no big deal. So main reason I want to go through all that stuff, so I want to show you one more thing before I do the example. What that was is that I wanted to show you here. Sometimes, using trigonometry, if I had, look at, for example, Just look at pi over 2, 90 degrees. So 90 degrees, and this makes, this is going to really freak you out because it's going to make this so easy for you. So before we use the calculator, let's look at sine of 90 degrees. And sine 90 degrees is right here. 90 degrees is straight up and down here. Show this right here. Oops. Bring it back here. It's getting messy. Show us up here. 90 degrees. So we know that when you're doing trigonometry, memorizing or visualizing the unit circle makes this stuff so simple and so easy. This is why I like talking about the unit circle a lot, because the visualization of this circle makes things so much easier. So we know that sine, for example, is the y value. And we know the distance from here to here is 1. So the sine of 90 degrees, before you use the calculator, is 1. Right? Think about it. Isn't that ridiculous? Ridiculously easy. Alright, so let's have a look at this and just to prove value. Let's go and make this, sine of 90 degrees. You guessed it. Has to be equal to 1. So the thing is, as we'll show you as well, what does that mean? Also means that the sine pi over 2 is 1. Now we just did it in radians. Who knew? Whatever. Because we know that pi over 2 is 90 degrees, and you get it. It's insanely simple. I don't know why it becomes such a big deal, but it's insanely easy. But another thing I just want to show you is right here. So basically, now looking at that, what we just did, this was really amazing. So let's look at the cosine of 90 degrees. So before we use our handy dandy calculator, cosine of 90 degrees is right here. So we know that cosine of 90 is the x value for 90, which it's not going to be moved left or right. So it's going to be in the origin. So cosine of 90 degrees has to be 0. What? Is it that simple? And also cosine of pi over 2, because we know it's 90 degrees, is 0. So let's check it out. Cosine 90 degrees. Wow. Who needs a calculator? Matter of fact, let's just really crazy with this. And let's go, what is the sine of 180 degrees? We can visualize it up here. Sine of 180 degrees, moving this down here. Moving this down here, sine of 180 degrees. Well, there's no up or down. So sine of 180 degrees has to be 0. So let's check it out. Sine 180 degrees equals, who knew? Amazing, eh? This is ridiculous. Why didn't you show me this? And then we can keep going. How about the cosine of 180 degrees? You're thinking, oh, you know the answer just now before I can write it down, because you know that the cosine is right here, and it's going to be minus 1. So the cosine of 180 is minus 1, or cosine, oops, I spelled it more, of pi minus 1. So let's try that. Cosine 180 equals minus 1. Wow. it's like really, you can do these before and faster than your calculator can do these. It's pretty crazy, hey? So the reason why I want to show you this is because, for example, this part right here, sine of 180 is 0, or cosine of 90 is 0. So what happens, for example, if I had something like this right here, let's solve it. This just comes from basic rules of algebra. If I had something like this, tan theta equals y over x, so sine theta over cosine theta. Well, that's fine as long as one thing. Everything we know about math and we started learning, it always said that we cannot have, we have, I don't know, this is 3 over 0. We call that, it's undefined, right? Doesn't matter exist. Can't do 3 over 0. Which means we can never have 0 in the bottom of the denominator. Even Siri knows that. Just ask Siri, what is 3 divided by 0? or even 0 divided by 0. So you know, it should tell you. So in the case, we can't have 0 in the bottom. So looking at this back here, you'll notice that when cosine is 90 degrees, it's 0. So basically, sine and cosine 90, we can't do it because it's equal to 0 in the bottom. And that's one of the things he says in your notes. You probably don't realize where he's saying it can't be 90 degrees or it can't be pi, right? Pi over 2. So you're basically looking back at the circle here. I want to go crazy with it. Doing the tan cannot be pi, tan cannot be pi over 2, it can be 2 pi over 4, and so on, right? So it can't be multiples of 90 degrees because we'll have 0 in the denominator, and that's where he goes, something like this, cosine theta not equal pi over 2, 90 degrees. That's why that's for. Okay, I want to explain that to you. So that's the radian measure, simplified, broken down, simplified, so that it actually makes sense for once. Yeah, you don't even need to do the conversion of multiplying by 180. What you need is just round a circle many times. All right, so having said all that, enough blabbing on. Let's have a look at the last part I want to show you. Is a question that he did in your book, and basically you see how it says here, secant x equals, or sorry, secant x is over tan x plus cotan x equals sine x. So what I'm going to do, the same thing he did in a sense, but I'm just going to do it a little slowly because I noticed as he went through, he skipped some steps. If you skip some steps, it's great if you know what you're doing, but if you skip steps and you don't know what you're doing, it can get confusing because you don't know where this stuff comes from. So in any case, looking back. So secant x is 1 over cosine x. And like we said before, substituting in tan x, we know tan is going to be sine x over cosine x, plus cotan is going to be flipped upside down, which is cosine x over sine x. And that's going to equal sine x. No way will that equal sine x. Well, let's pause for a second and let's break this down and do this piece at a time, because this looks really nasty right now. One of the things that I do when I don't explain something looks like cover it up, and I do this. So let's basically look at the bottom right here. How would we tackle that? If we just had that piece there to deal with, what would we do? Well, we were adding those two together. First thing we would do is get a common denominator. And the common denominator would be, this piece that doesn't actually explain well, would be cosine x times sine x over sine x times sine x plus cosine x times cosine x cosine I'll get it in a second. Cosine x over cos x sine x. All I did here is I went this one times this one, and then this times this, and this times this. And that's how I got my common denominator. Alright, now with that done, I can just take this away, and let's look at the whole big picture again. Move this on down a bit. And the top will become right here. Top is this then, 1 over cos x. Oops. That's all equal to sine x. Wow, you think you never get through this thing. But watch what happens now. This simplifies really easily because right here, sine squared, sine x times sine x is sine squared. Here we have cosine times cosine, which is cosine squared. So let's just start simplifying this down so it makes it look a little nicer. So I have 1 over cos x, 1 over cos x. On the bottom, I have sine squared plus cos squared over cos x times sine x. And that's equal to sine x. And it's just saying, no way, it's not. Well, it is, but what happens? So, when we get to here, this breaks down to something like this is the complex fraction. We have a fraction on the top, fraction on the bottom. How do we do that? Well, it's like saying this one divided by that one. So, making it simple and easy, we're going to do this. We're going to see. Actually, before you can go, let's make it simpler again. We know that from what we talked about before, sine x squared, sine squared x plus cosine squared x. We know now that that's Pythagorean theorem again, right? One of the first things we did is to start making these videos for you. So basically, let's look at this. This will make things drastically simpler. 1 over cosine. And doing these identities, it's all about recognizing this kind of stuff. That sine squared plus cosine squared is actually 1. And we're going to substitute that in there instead of sine squared plus cosine squared. Because we went back to the last video, you remember that sine squared plus cosine squared, remember sine squared theta plus cosine squared theta equals 1. So instead of writing this, you can just write that. That's where it comes from. So then on the bottom, we're going to have cosine x times sine x, and that's all equal to sine x. Now I'm going to go back to the part where I was talking about being a complex fraction. And I'm going to take this move down here, because now we're going to divide these two. And in division of fractions, there's actually really no division. So I'm going to have 1 over cosine x divided by 1 over cos x times sine x equals sine x. Now, basically, we would have one fraction divided by another fraction. The simple way I do it is to take the second one, flip it upside down, or use a word called reciprocal. And it looks like this. So I have 1 over cosine x multiplied by cosine x times sine x over 1. Now the beauty part happens. Cosine here cancels with cosine here. 1 and 1 is gone. And you'll see that in fact sine x, which is all I have left remaining, will be equal to my sine x on the other side. And that's it. All you gotta do is show both equal on both sides. You can work on one side or the other side, you can work on both sides at the same time. Doesn't make a difference, there's no real rules, there's one way to do this. So I can probably show you another way to do this if I had time, but it's getting late. So I'll pause there for now. In the meantime, have a look at these videos, tell me what you think, let me know, get back and tell me what you think, and we'll take it from there. And I hope this made sense, and I hope it clarified some questions for you. The good thing about videos that I like is that you can actually go back and watch them over and over and over and over again till it makes sense to you. In any case, stay in touch, let me know how you make out. Thanks, bye bye.